All right, let's see if this records. I'm having a lot of trouble this morning, afternoon, evening. Oh, I'm so tired. Trying to record sound. So let's see if this works. We're looking at scale drawings. So essentially, any map you have, or most drawings you have of stuff in real life, obviously they're not to scale. It's not the actual thing. In this picture of the school, you can see that down restaurants, coffee. Yeah, that's optimistic in Walla. You can see that down here, they've told us that the length from here to there is 50 meters. And if I get my ruler out and measure that, or I'd call that 1.2 centimeters in real life. Now, if I measure all the way along Klemke Avenue from here to here, well, that is 8 centimeters to there. I've got a short ruler. 8 centimeters to there and 7.2 centimeters to there. So it's 7.2 centimeters in the drawing. But what if I wanted to know how long it was in real life and I couldn't use the thing on Google Maps that you can literally use to tell you this? Well, in the scale, I've got 11 mil, was it? 1.1 centimeters means 50 meters in real life. This is the drawing, and this is real life. So if I've got 7.2 centimeters, I want to know how long it is actually. So we're going to get out our trusty divide times equals method. So we've got 7.2 divided by 1.1 times 50. And that comes out as, oh, I've got to get my phone calculator out. I've left my actual calculator at school, excuse me. Oh, do I have one on here? Oh, I never use this. So we've got 7.2 divided by 1.1 times 50, 327. Now, you don't often get ratios on maps looking like 1.1 centimeters equals 50 meters, yeah? You just don't. Usually, they'll look like 1 to 100 or something like that, which means 1 centimeter on the map is 100 centimeters in real life, which is 100 centimeters. That's a meter, isn't it? 1 centimeter on the map is 1 meter in real life. That's nice for a small kind of area. But if you've got like a road map and something's 300 meters long, then that's going to be 300 centimeters in real life. And that's a 3 meter long map. That's a big map. So these are the notes I want you to write. I'm just going to talk you through them. Scale drawings. A scale drawing has the exact shape as the original object, but is a different size. So for example, this one, that's the same shape, obviously, because it's literally a picture from above, but it's obviously different size because this is fitting on your screen. Yeah, it's obviously bigger than real life. I mean, smaller. The scale on a drawing is always written as a ratio. Now, this is important. We've got drawing length, ... the actual length. So if it's a scale ratio of 1 to 100, that means the real lengths are 100 times longer than in the drawing. So if you've got something 1 centimeter, that's 100 centimeters in real life. 2 centimeters, 200 centimeters in real life, you just times it by 100. If you want to know the scale factor itself, you do the actual drawing divided, the actual length divided by the drawing length. And if you know the scale factor, then if you want to find like another piece of information, to find the actual length, then you've got the drawing length, you'd multiply by the scale factor, drawing length, but you've got the actual length, you divide by the scale factor. I'll explain that. This last bit is just a reminder, quite often you've got to convert your units. So for example, if I've got 1 to 100,000, which is a fairly common scale, and it's 3 centimeters in real life, in the drawing, then I do 3 times 100,000. Well, that's 300,000 centimeters. Now, I've got to divide that If I want to go centimeters to meters, I divide by 100. And if I then want to go from meters to kilometers, I divide by 1,000. And that actually just equals 3 kilometers in real life. And they're the kind of scales you'll get more often. So the kind of questions you'll get thrown in the textbook is you'll be given a scale and you'll have to find the distance, and they'll give you like the smaller distance. So when they give you this is always drawing ... real, yeah? And team tip, the scale factor is literally, if it's 1 ... something, the scale factor is at something. So for this one, we're going to do 2 times, well, that's 20,000. So that's going to come out as 40,000 centimeters. Now, 40,000 centimeters isn't much use to anyone. So I'm going to divide by 100, and then I'm going to divide by 1,000 to turn it into kilometers. So it's 4Ks in real life. 5 millimeters, well, I've got 5 times 20,000 equals 100,000 millimeters. So I've got my 100,000. And if I want to turn that into like meters, how many millimeters in a meter? 1,000. So that's 100 meters. So if it's 5 mil on the map, it's 100 meters in real life. If it's 2 centimeters on the map, it's 4Ks in real life. 14.3 centimeters on the map. This is huge. We've got 14.3 times 200,000, no, 20,000. I can't even read the question. 14.3, what's that? 28.6000. Wait. 28,600? That's much better. No, that's not 28,600. No, this is 20,000. Why am I getting confused? Okay, I'm sick, by the way, so my brain's not working. That's my excuse. 14.3 times 20,000. Why 26? That's quite embarrassing. So we're never going to mention that again. No, of course you will. So that's 286,000 centimeters, yeah? Now, knowing something's 286,000 centimeters, not that much use to me. If you ask how far away the shop is and I say 286,000 centimeters, you're going to look at me like I'm an actual moron. So I'm going to divide by 100 to turn it into meters, divide by 1,000 to turn it into kilometers. So that becomes 2.86 kilometers, which is, I've stuffed something up. Oh, this must have been 0.4 kilometers. Yeah, because it's 40,000. I'm dividing by 100 and then dividing by 1,000. Oh, gosh, you guys. All right. This time, we've got our scale factor. We know the real lengths, but we're trying to find the smaller lengths. So the question above, we were trying to find the actual distance for the smaller distance. So to do this, we times by 20,000. If you're going the other way, if you're trying to find the smaller distance given the actual distance, we're going to do the opposite. We're going to divide by, this time it's going to be 500. And then convert. So we've got 50 divided by 500. That's going to give us 0.1 meters. Now, 0.1 meters, not that useful. So we're going to times it by 100. And that equals 10 centimeters or 100 mil, whatever. Okay, 75 centimeters divided by 500. So 75 divided by 500, 0.1. This is 0.15 meters. Again, not that useful. So we've got 0.15. We're going to times it by 100. Oh, this isn't meters. This is centimeters. And this is centimeters. And this answer was, oh no, that one was meters. This one's centimeters. I'm getting so confused. This is 0.15 centimeters, yeah? Now, that's not very useful, knowing that something's 0.15 centimeters. I think I'm going to times it by 10 to turn it into millimeters, which gives me 1.5 millimeters. So if it's 75 centimeters in real life, I wanted it to be 1.5 mil in my model. Okay, 4550 millimeters divided by 500. Okay, 9.1. That's already a nice answer, isn't it? It's 9.1 mil. If it's 4,550 millimeters in real life, which is like bit over 4.5 meters, then it's going to be 9.1 mil on my drawing, or in my model, sorry. Okay, this time we're actually finding the scale factor. So we're going to do the scale factor equals actual divided by drawing. So in the actual thing, it's 50 centimeters. We're dividing it by 4 millimeters. Unfortunately, it's no use, like we can't divide that straight away because they're 1 centimeters and 1's meters, yeah? Have a look, that's centimeters, that's meters, millimeters. So let's get them both the same. So if we times this by 10, then they're both, because there's 10 mil in a centimeter, then this is 50 centimeters is 500 mil. We're dividing by 4 mil. So that gives us, divided by 4, 125. So it's a scale factor of 125. And if we've got an actual length of 0.1 mil represented by 3 centimeters in the drawing, oh, so we're blowing it up. So here the scale factor equals, again, actual over drawing equals, well, we've got 0.1 millimeters over 3 centimeters. We're going to times that 3 centimeters by 10 because I want them both to be millimeters. So we've got 0.1 over 30 millimeters, 0.1 divided by 30. That's a great scale factor. 0.0, that. And now it's not letting me. Although we would probably leave that as 1 over 300. You would literally just chuck this in your calculator and press S to D to give you 1 over 300. This one, if they wanted the scale factor, so the ratio is, well, we'd do 1.125 here. So the ratio is, you know how we've got 1 over 300? That means 300 ... 1. So that's these ones. I would now like you to go on to the next activity. Oh, sorry. The next activity, we'll be writing these down. So hopefully you were writing these as we go and pausing at relevant spots. I'll have this PDF of this page so you can copy it down. I know it's a lot of writing, but we'll be practicing this for like 2 lessons. So, I mean, this is your writing done now, which is, kind of nice. I hope you have a good rest of the day. And once you've done these, I have some more activities. Just keep going through the list. Thank you very much.